Hey students, this is lesson 413 part A. We're going to learn some laws of exponents that we're going to use to simplify expressions with exponents. And I'll try and explain each one of these laws for you. The first law here is called the product law. I'll underline that one in red. And what it says is if you have two exponents and with the same exact base, notice there's a in both of those, that you can just add the exponents together. And I'll just give you an example of that one over here. So let's say I have, let me pick a number here, like say, let's say I have 3 to the second and I want to multiply that by 3 to the third. Well, all I really need to do here, since 3 to the second is 3 times 3, so 3 squared is 3 times 3, and 3 to the third is 3 times 3 times 3. And when I multiply those together, you can see that I have 5 factors of 3, which is exactly what I get when I add 2 plus 3. So that's where this product law comes from. Just add the exponents if the bases are the same. And another product law is this one. I'll do this one in green. A to the c times b to the c is equal to a times b to the c, and I'll give you an example of that. So let's say we have like maybe 3 to the second power, and we have some other base to the same power, like maybe 4 to the second power. Well, really that's 3 times 3 times 4 times 4, which I can also write as 3 times 4 times 3 times 4. And you might notice here that I have 3 times 4 twice, so I can just do 3 times 4 to the second power, which is just 12 to the second power. So that's an example of the product law. So if the powers are the same, you can just multiply the two bases together and use that power. I'm going to need a little more room here to show these other ones. Quotient laws. Notice here we subtract the exponents when we have the same base. And that makes sense because when we were multiplying over here, we added them, and division is really the opposite of multiplication, so it kind of makes sense that we subtract, but I'll give you an example here. So let's say I have 2 to the 4th, and I want to divide that by 2 to the 2nd. Well, if I expand those out, that's really this. And every time I do 2 divided by 2, that's just equal to 1. And 1 times anything is just a number, so I can really cancel those. They're not going to make a difference in the final answer. So those both cancel, and I end up with just 2 times 2 on top, which is 2 to the second. And it also turns out that 2 to the second is the same as 4 minus 2. Now you might be thinking it's the same as 4 divided by 2 also, so maybe that wasn't such a good example. Let me try 2 to the 5th divided by 2 to the second. I'll show you one more time. So we expand that, and we have 5 factors of 2 divided by 2 factors of 2. Every 2 divided by 2 cancels because it's equal to 1. And we end up with 3 left, which is 5 minus 2. So 2 to the 3rd power. So quotient law, you subtract them. All right. And now we'll do this other quotient law, which says if the powers are the same, you can just divide the two bases. So an example of that would be like, let's say I have 6 to the second, and I want to divide that by 3 to the second. So expanding that, I get 6 times 6 on top, 3 times 3 on bottom. And you might notice here that we have 6 divided by 3 twice. And 6 divided by 3 is just 2, which is 2 times 2, which is 2 to the second. And if you take 6 divided by 3, you get 2. So that's an example of that quotient law. All right, the next law is the power to a power law. And that says if you have something in parentheses, like say the second power, and you raise that to some power like 4, what this is saying is you multiply the two powers together, the 2 and the 4. So this should equal 3 to the 8th according to this law. And let me just show you that that is true. This 4th power here, when I operate on that, that's telling me that I'm multiplying this base 3 to the 2nd by itself 4 times. And each of these are 2 factors of 3. And you can see we have a total of 8 factors of 3, which is what I get when I multiply 2 times 4. All right, and the one other law you should put on here so you don't forget it is any number to a negative exponent is equal to the reciprocal of that number, or 1 over that number with a positive exponent. All right, I'm going to do a couple examples here, and then we'll do the rest of the work in class. All right, let's do a few examples here. So the first one says 10 to the negative 4th times 10 to the 3rd. Notice we have the same base. So the property I should use here is this one right here, this product law, which says if you have the same base, you can just add the exponents. So I can just write this as 10 to the negative 4th, negative 4 plus 3. And negative 4 plus 3 is really just negative 1. And when you're simplifying, we like answers not to have negative exponents. So we're going to use this property also over here, where 10 to the negative 1st is just the reciprocal of 10 to the 1st, and 10 to the 1st is just 10. So we're going to leave our answer as 1/10 there. All right. I'm going to do this one next. This is an example of using this one right here, the power of a power law, where you have an exponent and you're going to take that exponent to a higher power. So this rule says that, notice I'm BC means B times C. I'm just multiplying these two. So 3 times 2, that's a time symbol, not a decimal there. And so that's 2 to the 6th power. All right. And in all these examples, I'm either going to leave my answer as a power just to demonstrate these properties most of the time. All right. In this one, we're dividing, so we're going to use a quotient law here. Now, when you're dividing, you can separate out the fractions this way. So you can do 10 divided by 5 by itself, and then we're going to do a to the 4th divided by a. Now I'm going to write a as a to the 1st because any number is the same as the number to the 1st power. And now I'm going to use this law right here, quotient law, and that says you need to subtract the exponents when you're dividing. So I'm going to do 10 divided by 5 is just 2. And a to the 4th is just a to the 4th minus 1 using that quotient law. And that's the same as 2a to the 3rd in simplest form. All right. We're going to do one more here. I'm going to do this example here. And actually, I don't see this law up here, but there's one more rule that we can use, and that's this. If you have some product and you want to raise that to some power, say, and you have to do everything inside that, every factor inside the parentheses for that power. And just to give you an example, let's say I had this 3 times 2 to the 4th. Well, that's the same as 3 times 2 times 3 times 2 times 3 times 2 times 3 times 2, right? I need to do that base 4 times. Well, notice I have 1, 2, 3, 4 factors of 3. So 3 to the 4th. And I also have 4 factors of 2. 2 to the 4th. So that's how that one works. So we're going to use that on this one right here. We're going to do m squared to the 5th times n to the 4th to the 5th. And that's going to give us, now I need to use the power to a power law. So we're going to do 3 times 5 here using this law. That's 15. And then for the n, we're going to do 4 times 5, which is 20. All right? That's the end of the video. I'll see you in class.